Look across a productive agricultural pasture in California, Washington, or South Australia, and you'll see an idyllic, pristine environment designed to feed thousands of livestock. But that peaceful green surface hides an aggressive alien invader, originally from Western Europe and North Africa, Carduus tenuiflorus, commonly known as the Slenderflower Thistle. Left unchecked, this plant grows up to 2 meters tall, forming dense, impenetrable walls across disturbed land. This invasive plant is a severe economic and ecological menace, capable of ruining agricultural trade and entirely displacing native ecosystems. The thistle actively defends its territory. It grows thick, needle-like spines that physically block livestock from moving through the pasture or reaching fresh water. Beneath the thorns lies a secondary, invisible threat. The thistle is a nitrate accumulator. This diagram shows exactly how the threat moves from the ground to the animal. As the plant pulls nitrogen from the soil, it hoards high concentrations of nitrate in its tissues. When cattle or sheep ingest those tissues, it triggers lethal nitrate poisoning. Land managers are forced into a high-stakes corner: eradicate the plant entirely or risk the lives of the herd. To defeat the plant, you have to reverse engineer its life cycle, starting with its stealth phase as a winter annual or biennial. The seed germinates in the fall and immediately forms a leafy rosette, growing entirely flat against the freezing ground to avoid early grazers. As the weather warms, it undergoes a rapid spring transformation, shooting upward on strongly ribbed, slightly woolly stems. This is when it develops its physical armor. Notice the continuous ribbon-like spiny tissue running all the way up the stalks. It is paired with deeply lobed, needle-tipped leaves. By hiding low through the winter and armoring up in the spring, the thistle perfectly outmaneuvers both seasonal elements and hungry herbivores. By May, the blooming phase begins, producing stalkless, pinkish-purple flowers tightly bunched in clusters of 3 to 10. This visualization demonstrates the plant's staggering reproductive scale. A single flower head can multiply into an astonishing 20,000 individual seeds per plant. The primary dispersal mechanism relies on the wind. Each seed is equipped with a pappus, a detachable parachute of white hairs that catches passing gusts. The seeds also act as hitchhikers, traveling long distances in contaminated soil, caught in livestock coats, or wedged inside agricultural machinery. The plant's true danger lies in this capacity for unstoppable, exponential replication. Brute force alone cannot stop the spread. Farmers have to rely on integrated weed management, allowing strict biology to dictate the counterattack. This timeline chart plots the plant's life cycle, revealing a narrow kill window. Herbicides like triclopier or aminopyralid must be applied exactly during the early seedling stage. Applying chemicals late, or simply mowing, fails entirely. It only delays the inevitable blooming and seed drop. Another tactic is cultural control. Farmers will intentionally let the surrounding pasture grass grow tall to directly compete with the thistle for sunlight. Shaded by tall grass, the thistle grows spindly, failing to develop strong spines. This allows sheep to safely consume the weakened weeds alongside the grass. Effective management requires using the plant's own biological requirements, like light and timing, as weapons against it. When chemistry and pasture management fall short, scientists open a final front, importing the thistle's natural biological enemies from overseas. Researchers introduced Rhinocilus conchus, a highly specific seed-feeding weevil from Italy, to consume the plant's reproductive core before the seeds can drop. Another biological agent is Puccinia cardurum, a rust fungus designed to cripple green leaf tissue. The infection starts as tiny yellow specks, erupting into thousands of reproducing rust pustules. These unleash a microscopic payload of golden brown spores, rapidly spreading the disease from plant to plant. Even with these advanced biological tools, basic biosecurity remains mandatory. Vigorously cleaning tractors and boots before leaving a field is the only way to stop the seeds from hitchhiking to new ground. Defeating the Slenderflower Thistle requires a permanent, integrated war of chemistry, ecology, and relentless human vigilance.